Good morning, everyone. My name is Vishwas. Today we are going to learn about rules for image formation by concave lens and how to draw the image formation or decide where the image will be formed with the help of concave lens. So let's see the first rule. A ray of light parallel to the principal axis appear to diverge from the principal focus located on the same side of the lens. Let's try to understand this. This is the principal axis, this is a concave lens. So what happens in this case is when a ray of light is going parallel to the principal axis, this is principal axis, and this is the ray of light which is going parallel. And the concave lens property is to diverge the beam of light. So it is diverging, but when we extend this ray of light at the back, it appears to be passing through the focus. So I have told you in case of mirrors also, whenever a ray of light will be parallel to the principal axis, it always pass through the focus of the mirror or lens, right? Next is a ray of light appearing to meet at the focus of a concave lens will emerge parallel to the principal axis. What happens in this case is this is a concave lens again. So when a ray of light is falling at a particular angle that it will pass through the focus, so what will happen? It will become parallel to the principal axis. In the next case, if a ray of light will pass through the optical center of the mirror, it will go straight without any kind of bending or deviation at any of the angles. So whatever the angle it is making with the normal or the principal axis, the same angle it will make with uh, after refraction from the lens, right? So next is ray diagrams of image formed by a concave lens. We have understood the rules. Now let's do some practical work how the image will be formed in case of a concave lens. When the object is at infinity, right? So image will form at f1. Let's see how it is. The rays are coming from infinity parallel to the principal axis, and the concave lens is diverging those rays in this manner. One is here and the other one is here. So when we extend the rays on the same side of the lens from where the object has been placed or the rays have been coming, so these rays when get extended at the back, what will happen? It will appears to be meeting at the focus of the lens, right? Okay. Now, in this case, what happened is, as it is meeting at a very small point and it is intersecting at focus on the principal axis, then you can see the point size image is getting formed over here. And what kind of image, nature of the image will be virtual and erect, right? Because in this case the image should be formed over here, but it is forming on the same side, and it is a kind of imaginary image. That's why we call it virtual and direct, right? Next is when object is placed between infinity and optical center, that means somewhere around here, right? So what happens in this case is the image is formed between f and o. The image will be formed between f and o. What will happen now? Now you can see that in this case also the image is getting formed as virtual and imaginary, that is on the same size as that of the object. So you can again see this, there are two rays. One is passing through the optical center and the other is parallel to the principal axis. The principal axis, the parallel ray the ray which is parallel to the principal axis, what will happen in that case is after diverging, when we will extend that ray at back, it passes through the going and passing through the optical center of the lens. So here at this point, both the rays are getting intersected. So what will happen in this case? The image will be formed over here that we will denote it as A dash and B dash. As you can see, it's not a point size image, but it is a smaller image as compared to that of the object. So what will we call it? Diminished image. So nature of the image is virtual and direct, and a diminished image is formed, or you can write it as smaller images also formed, right? So today we have learned about the cases of concave lens, right? So let's go further. As you have observed, in the focal length of the convex lens is always positive, and there are few sign conventions for the spherical lenses. It is almost the same as that of the mirrors, but almost not all. Sign conventions are as that of the cycle mirror except the measurements taken from optical center of the lens. For example, focal length of convex lens is always positive and not always positive. It's always positive basically. Focal length of concave lens is negative. Now the lens formula, like we were having mirror formula, we are having plus sign over here, but in this case 1 by v minus 1 by u is equal to 1 by f. And similarly in magnification we were having minus sign in case of mirrors. In this case we are having plus sign, right? So it's height of image upon height of object, that is equal to image distance upon object distance. Now power of the lens. What do you mean by power of the lens? Power of the mirror nahi hoti, it's not possible, but power of the lens is there. Power of the lens is the reciprocal of its focal length. That means 1 upon f is you got the power of the lens. So formula for power of the lens is P is equal to 1 by f, right? P is equal to 1 by f. And you can write it from the above relation of the lens formula also, that 1 by v minus 1 by u also. But P is equal to 1 by v minus 1 by u also. So the SI unit of power is diopter, that is denoted by capital D, and it is denoted as the reciprocal of the focal length in meter. And one thing you have to keep in mind, if the focal length is in centimeter, you have to convert it in meter in this. Because when you are writing the unit as diopter, SI unit as diopter, that means you have to convert that focal length into meter because diopter is 1 upon meter, right? So the degree of convergence or divergence of light is expressed in terms of power. That means how much it will converge or diverge. That is, when you go to the doctors, doctors used to say you that your number is plus one, plus two, plus three, or minus one, minus two, minus three. That depends upon what kind of lens you are using and what is the power of that lens, right? If the doctor says that it's plus one, that means it's a convex lens. If the doctor says it's a negative, that is known as concave lens. I have written this, you can note it down. That's the most important point. While doing numericals, you have to take care of all these, right? So power is 1 upon focal length. Focal length basically increases or decreases the thickness of the lenses. And in case of combination, the power is 1 by P plus, not 1 by P. In case of series combination, it will be P1 plus P2 plus P3 and so on, right? So today we are going to do till here only. In the next video, we will come up with a new topic and few question answers we will do. So stay updated, stay safe, stay at home. Thank you and have a nice day.